Hello. Today we're going to talk about memory mapping, how to understand where the computer actually holds the data that you're programming in your Java programs. First, we want to talk about two general types of data. There are primitives, which are the 8 primitive types, and then there are objects. So the primitives, the integers and the doubles and so forth, are stored in a memory location called the stack. Objects, which are one of a class, an interface, or an array, a reference, an address to the object is stored in the stack, but the object itself is stored in memory called a heap. So we'll see how to represent those diagrammatically. So here's an example of a primitive copy. If x and y are ints and x is set equal to 20, then y equals x just copies the value of x into y. Copying an object class is different. There is a reference copy, what's called a reference copy, and then there are object copies, shallow and deep copies. So here's a reference copy. It's not really a copy at all, but it's a reference variable that points to the same object that an initial reference variable pointed to. Notice there's only one new to create one object. But now at the end there's two references pointing to the same object. So those are two locations in memory called the stack and the heap. An object copy creates a copy of the object itself. Notice there are two news. In other words, two examples of creating an object. The second one assumes that a car class has a copy constructor. So the result of this is this. The two car objects each pointed to by a separate reference variable. What we don't know is what is inside the car object. So a shallow copy copies the main object but doesn't copy any of the inner objects. Let's say the car object had an engine object and a wheels object and a whatever. The inner object would be shared. So here's another example. Let's say you had a student object. And the student object, as well as the last name and first name and M number or whatever, also has a pointer to the course object that he or she's enrolled in. So here's an example of how that looks. So a shallow copy creates a second student, student 2, but both objects share the same course object, like this. And if you changed the course in student 2, in student 1, it would affect student 2 because they share the same copy. A deep copy, on the other hand, is completely separate from a shallow copy. From the objects are completely separate. And here's a diagram of it. If we copied our student 1 object, we'd copy the entire object structure. And if we changed the course in student 1, we'd not affect student 2. So here's some code. And notice the red lines. The shallow copy just says that this dot course equals s dot course, where s is the other student. It's just creating a copy of the course of the reference variable. And so the driver would call it, and if we changed CMSC in student 1, it would also change in student 2. So here's an example of code in a deep copy. In the deep copy, we have another, notice the red line, we have a second instance of new, the new data type, new keyword, and we're creating a new course with the same course name and course ID as the original one. So now if we had the driver doing the same thing, here's the original data, and then we change the course from 204 to from 203 to 204, but only student 1 changes. That's because the course in student 2 is totally separate. So copying to arrays, it's just like copying objects. Remember I said that an object is stored as it could be considered an array, an interface, or an object itself, or a class. So here's an example of the stack and the heap. The stack stores, now it doesn't store a primitive, a value, it stores a memory address, and we represent a memory address as an arrow pointing to the location in the heap. Notice that puppies is outside the stack because the name of the variable, the name puppies, doesn't actually get into the machine code of the program. The JDK, the JVM, keeps track of the variables. But inside the array, there are 5 different dog types. I call them pup1, pup2, and so forth. So this is a reference copy is the code down below. We just return the same value that came in for some reason. So now a shallow copy, when we're talking about arrays, notice copy and puppies are still outside this stack, and each of them are memory addresses that point to a new array. So the new array copy is a new array of dog, which is the same length as puppies that came in. But also notice down below in the for loop that we're just pointing to the same instance of the array, same element of the array. Now in a deep copy, we'll create a new array, new dog of puppies.length. But also inside the for loop, we also create a new instance of each dog. So we have another copy of pup1, pup2, pup3, and so forth. The thing to recognize in a deep copy is that those 2 arrays are totally, totally separate. There's nothing that you would relate to that where you change one and it affects the other side. So in our memory map lab, we have a couple situations. These next few slides are very close to the lab. Notice first of all that the order that things are put in the stack, the first thing is an array of int. So it goes at the bottom of the stack before we're even thinking about B. But A is an array of int, so it's a memory address, and we represent the memory address by the arrow. The arrow points to the array of 6 integers, the default value of an int is 0, so that's what's in the array. Then next, this primitive b, which is set to 1, 2, 3, 4, that's put on the stack. A and B are both outside the stack. The primitive is in the stack. A's value is the memory address, which is represented by an arrow. So in this, we have an array of string called Z. Z is a new array. A new array of string that's size 3. And we loop in a for loop through each of the 3 elements of string of Z. And we give it number space plus I, and in this case 0, 1, or 2. Now strings are objects, so they're referenced by the element of the array. They're not inside the array themselves. Here's an example of a shallow copy. We have students. We're assuming that student S1, S2, S3, S4, S5 are already defined outside of this these slides. And so we have an array of students and we copy that array, but we don't copy the individual elements, we just do a reference copy. So each of the elements that were in students, S1, student sub 0 is S1. It's equal copied sub 0. It's also S1. And a deep copy, notice that here that we have the 2 arrays, as in the shallow copy, but each array points to totally separate objects. So the important thing to remember that is that in a deep copy, the 2 objects or arrays or interfaces, but arrays or objects are 100% disjoint. That's the big thing to remember about a deep copy versus a shallow copy.